Hi. I have
Okie dokie, everybody, we're getting started. Whee! So, hello everyone. This is the second part of the technology deep dive on BGP. And hopefully you saw the first part, which was on Sunday as an afternoon tutorial. If you have not seen it, it is available on YouTube and it's really good. And I have to tell them it's really good. So this is going to be the second part. Even if you haven't seen the first part, the second part should still make sense. And I think that that's it. So take it away.
Should
Jeff.
make as much sense as the first part.
Exactly. So thank you everybody for coming. So the first section was basically BGP for protocol developers. If you didn't know much about BGP, looking through this room right here, we see a lot of people that know anything from a little to an awful lot of BGP, or at least in one case actually helped write the thing.
Right, there are several people who should be up here instead of us, but we're the ones who are the suckers and said yes.
So this is the point where I should actually get out the clicker because we actually went in advance. So you'll note in the data tracker, this is called the dump truck session, not because we specifically wanted to do dump trucks, but because Warren really, really likes dump trucks. But we'll work it into the talk anyway. So a little bit about us. So I've been doing BGP for less time than this guy here. Currently, I'm one of the IDR chairs, so part of my day job is figuring out how to do the new things and try not to break all the old ones. I've been doing this roughly about 2000, and I have a small background as an ISP.
Similar things, not quite as small of an ISP. Started a little earlier. Next.
So one of our favorite quotes from Dr. Tony P. BGP is a very useful tool. It's very sharp, and occasionally you get cut by it. So part of the talk here is discussing how things have worked out well for us, and sometimes how they actually don't.
So yeah, BGP was invented because the internet needed a routing protocol that wasn't EGP. It really did. And then BGP4 was invented because the internet needed classless routing. And since then, it's hung in there a long time. So yeah, it stabilized at version 4 in 1994. And let's see, counting my fingers, and it's been a few years. So yeah, Jeff has a nice presentation on YouTube if anybody wants to dive into a lot more of the historic minutiae. But like why it didn't die 20, 25 years ago is because it has just enough and just the right kind of extensibility features.
And probably the biggest thing about it is BGP has to be incrementally deployable. Every time you add something new, you can't break everybody else, or at least you hope you don't break everybody else. We'll talk about that throughout the slides. And the second part is, when you actually do want to deploy the features, figuring out how you actually scope that is an interesting set of challenges. So What's actually interesting out of BGP, if you're somebody that's a routing geek, well, BGP is a path vector protocol. And what does that actually mean? Well, you know distance vector fairly well. The distance in this case is theoretically a list of autonomous system numbers. It's the thing that BGP actually uses. A lot of this stuff at the beginning, especially, is going to be very BGP 101, especially if you attended the Sunday talk. But the important things here is that if you are doing BGP, there are two different sort of primary scopes you worry about. Internal, where basically you're expected to be full meshed. Everybody gets the same routes as everybody else. And external, and that's the place where interesting stuff is expected to be happening.
And the internal has semantics that are kind of sort of a little bit like IGP semantics, although not really.
Yep. So what's the state being passed around BGP? Well, routes are destinations. We call them network layer reachability information, because we like long words, and a vector of path attributes. And for a lot of people, especially if you've spent time doing other stuff, anywhere else, it's a key value protocol. At this sort of high level, you have a sense of how it works. Most important one of these things is the actual AS path, which is the vector of ASs that stuff is passed through. And important thing about BGP, operational practice is mostly done through policy. Configuration that lets you actually control what's accepted by BGP, how it gets propagated, how it gets used. BGP is actually a pretty straightforward protocol until you actually try to make it operate. That said, BGP runs over TCP port 179, and we have to put this stuff in something.
Yeah, so it's widely observed that BGP carries around a lot of different stuff, and it's kind of just one more case of the old syllogism. We have to put the data in something. BGP is something. We have to put the data in BGP. Yeah.
So the problem is people have very strong opinions about.
Oh, actually, can you back up one thing? There's one thing I did want to cover, which is that people like to talk about how they want to flood their data, so they're going to put it into BGP because BGP is awesome for flooding. And really, no, BGP doesn't flood. There is like no flooding feature anywhere in the protocol. That's not a thing. It doesn't exist. However, it does give you distribution semantics that end up getting routes everywhere as it's normally configured and deployed.
Yeah, it is actually very chatty as it's doing that. Convergence for BGP is source of several papers, and we're not going to cover those today. Like I was saying, people have very strong opinions what you actually should carry in BGP. And one of the things that you have in IETF is if you are constantly being asked to put strange things inside your protocol, well, it's popular. DNS is another favorite thing that people want to put stuff inside of. They're popular. And the problem is when you're starting to look at, what can you actually shove into these things? People start making analogies. Hence Warren, it was like, is the protocol a dump truck? Are we going to throw all this stuff in here and carry it around? It's large, it's solid, it's doing its job well. And maybe, if it's really successful, it's an even bigger dump truck. The trouble is, people that usually start talking about these things as being a dump truck, well, what they actually think is a different kind of
Not
truck.
everyone sees it the same way.
So if you're going to carry stuff around, you're going to have opinions, and a lot of this breaks down in terms of, not should the protocol carry the thing. Clearly, we have had success carrying all sorts of stuff inside of BGP, but we're concerned in our operations about when we're carrying it around and does it go to where it needs to. Just because you have a dump truck or a garbage truck doesn't necessarily mean everybody wants you to stop by their house.
So, yeah, what do we use to carry in there? Well, hopefully the IPv4 and IPv6 routes are not a controversial use for the protocol. If they are, it would probably be time to end this session. And obviously IDR, which Jeff co-chairs, is the main group that looks after standardizing the core protocol. There's also the GROW group that is kind of the ops side of talking about how BGP is deployed and used. And Grow and IDR work together hand in glove. No, they liaise pretty well. So, but wait, there's more.
Yeah. Clearly, the first things we carried in were just IP reachability, and that was enough to keep people very busy for a while. Eventually, we start putting in exciting things like virtual private networks, and that blossomed into 2 or 3 versions of the group that is now best that carries stuff around. FlowSpec is an absolutely exciting and useful and absolutely terrifying going to blow up the world thing as well that gets carried in BGP. It's its own talk. I gave a chat at a prior NANOG about how useful it is and how it has also caused terrible things in the world. But the problem is Dr. Tony P said earlier, these things are sharp. You will get cut sometimes, so be careful what you're carrying around. Some other places that we get some use is that we can carry link state in there. There's a BGP link state protocol mechanism that is also used by the link state vector routing group. And we have a lot of exciting stuff that's been going in there. An awful lot of segment routing in particular takes advantage of the fact that you could actually program segment routing using link state mechanisms.
As an aside, I will point out that pretty much anything, I think anybody who's done any work on a protocol that's been around for a while has eventually worked out that no matter what you think you're writing your protocol to do, that's not what it's going to be for 10 years later. So BGPLS was absolutely positively only there to allow monitoring stations to extract link state information because they didn't want to snoop on the IGP because that would be rude. It's definitely not supposed to be used for anything operational. I think we probably, if we go back into the minutes of IDR meetings where it was being discussed, we will even find that. Oh, oops.
Yeah, thou shalt not carry extra stuff in link state. Well, thou art doing so. Why is BGP a popular protocol? Well, as I was talking about earlier, it's popular when the protocol and its deployment model in particular gets aligned with additional use cases. As John's saying, well, BGP doesn't really flood things. You throw it in there, it does go around, and just as importantly, it actually passes across multi-provider boundaries. Now, this is something that most of our IETF protocols don't have as a generic feature. So this is often the motivation to at least look at BGP for these sorts of things. And of course, going back to the earlier slide, if it looks like a key value protocol, it looks like a generic TLV thing that you can just stick an extra thing in there and it goes along for the ride. That's a happy thing. Now, the trouble is, if you have all these properties, it's easy to do it. Sometimes if you can't stick it in TLV, maybe you just create a completely brand new address family for this stuff. And if you can put it in address family, you can put it inside of a path attribute, you can do this as an inter-domain thing. Does everybody want the dump trunk pulling up to their house? Not usually. So the operational model matters.
So yeah, problems with putting everything into the dump truck is that it slows the dump truck down. The dump truck has to drive a longer route, and maybe you put so much stuff into it that it breaks. Hopefully not that. So this is both true when thinking about the implementation of the protocol, but it's also true when just thinking about actually moving the data through the network.
So of course, one of the issues, as we were discussing with FlowSpec, is there's consequences when things go wrong, especially if everything is inside of the same dump truck. So theoretically, the internet's not a research project anymore. We make a lot of our money, for people in this room, getting things actually done. Anything from the trivial of carrying cat videos to helping remote surgeries happen to interstellar travel. BGP is the internet's routing protocol, so we care about it for doing everything day to day. And the trouble is, when something goes wrong, BGP is often part of the root cause for large-scale outages. BGP is just a routing protocol. It's software. Sometimes it's just bugs. And we talked about how policy is important, how things are deployed, operations matter. And unfortunately, it means how you actually build your implementations are going to impact that. Really, and Unfortunately, this goes back to my peachy coocher for last night. Sometimes complexity is your enemy. The more complex things are, the harder it is for operators to do things. And when you're doing this in a massive distributed system like BGP, this is going to be a problem. So it's no surprise that people are very sensitive about what goes inside of the thing.
I have a tiny footnote on that slide, which I've seen at least one paper that purports to prove that BGP is Turing complete, meaning that if you deploy enough BGP routers and you deploy just the right policies on all of them, you can make it be Turing complete. If anybody actually has a citation for that, maybe you can drop it into the chat. I certainly don't remember what the paper was or where it was published, but I think that is a great demonstration that definitely you can configure it in a way that is probably too complicated to reason about.
So the question is, if this is so important and we've actually gotten the useful things done, why don't we just stop and declare victory? Well, sometimes it's just the right place to do the work. One of the challenges we've seen at IETF is we do have popularity. These are because we have use cases that need solutions. People have problems need to solve, and sometimes we have the right place to do it. And the question is, how do we actually do it on the safe side of things? And the big things we have to worry about is scoping. BGP is primarily, as a protocol, interested in two flavors of scoping: where the reachability itself can go, and for the stuff that's inside of this giant stack of TLVs called path attributes, how are those scoped?
So yeah, we talked about this some on Sunday, but the base protocol, the base BGP protocol, just does IPv4 unicast. And if you read through that whole RFC, you will see encodings for IPv4 prefixes, and that's all. Because of the fact that we have these path attributes that are extensible in just the right way, it gives us the ability to wedge other stuff in there, including, first of all, IPv6 routes, but later, lots and lots and lots of other things. Basically, anything that so Jeff talked about BGP being, more or less, you can think of it as a generic, although very kind of weirdly non-orthogonal key value protocol. The extension that gave us IPv6 support gives us pretty much arbitrary key thing support. You define an AFI-SAFI, that's your code point into that particular database of keys. Yeah, and the other thing, the other attribute of that, aspect of that, is between any given pair of BGP speakers that are talking to each other, they send what's called a capability when they initiate the session to tell one another, I support this AFI-SAFI combination. If it's not advertised, it's not supported. And therefore, the scope of how any given AFI-SAFI can travel is scoped by the connected set of BGP speakers that support that given AFI-SAFI. Unless we talk about things being leaked from one address family to the other, we're not going to talk about that, are we?
So for the most part, scoping, again, very important. The trouble is the biggest scope that we have today is the internet. So when stuff does cross over into internet scope, things can get very interesting. So the other problem is, what do you actually carry your sessions on? And how many sessions do you keep when you could keep all your eggs in one basket, or you can have separate baskets? BGP is quite happy to carry every one of those address families all on the same session. Sometimes this is not a great idea. Talking about link state, in theory, that was expected to be completely separate. In practice, people just carry it all on the same one because it just works most of the time. Sometimes you want to actually carry the address families together because there's actually usefulness for your bundling. You do want, for example, your labeled unicast for MPLS to go across the same family that carries your IPv4 because you're going to use it for tunnels. And sometimes you have reasons to split these things. Ideally, you're analyzing things for safety scaling, and sometimes just operational complexity. Do you choose to go for all together, or do you go for splitting it up? Structural segregations, ships in the night type things are very important for safe operations of BGP, and just as importantly mean that just because the protocol can carry things all in the same protocol doesn't mean that you have to deploy it that way.
4 words, head of line blocking. Yeah, so how do we extend BGP? Everything's TLVs. It's TLVs all the way down. Oh, and by the way, there is unfortunately not a completely uniform set of conventions to how the TLVs are built at every level, which is regrettable but true. But anyway, the more or less the rule of thumb that practitioners use is extend an existing attribute when you can, because among other things, we have a fairly limited universe of code points for path attributes themselves. It's just a 1-byte field, type field. But if you need new semantics, then you define a new path attribute. And a huge part of the sort of success of the viral nature, if you will, of BGP is because it's possible to add path attributes that are what are known as optional for reasons that we covered on Sunday, and transitive. And the transitive part means that if I'm a router that speaks attribute foo and Jeff's a router that doesn't, and Warren does, well, I can take my optional transitive attribute, give it to Jeff, he'll look at it and say, I don't know what this is, but it's transitive, and he'll give it to Warren, who will then look at it and explode because I formatted it wrong. But I led us into a slide that wasn't the right slide. I mean, it was. My talking was the wrong talking.
No, that's the right answer. That's next slide after that. But it's like sometimes you have to decide, where the stuff should go. Filtering path attributes becomes part of this equation. If everybody needs to be able to pass stuff around, well, sometimes we don't want them to go everywhere. So being able to selectively pass them along, filter them, is sort of interesting. If you're doing the optional transitive stuff, the whole point is the ignorant router can pass it along to the all-wise one, and theoretically it knows what to do with it. But that transitivity property is, as John's saying, part of the problem sometimes.
So what are we on here?
Redistribution.
Why don't you talk to this one?
So, part of the problem is that as things get passed around, we're talking about the biggest scope that we have right now is the internet. So when we're talking about things that look like IP reachability, which a lot of our best style protocols are actually doing, it's often the case that the protocol mechanism contains IP. So our layer 3 VPN stuff, passes around these labeled routes that have things like route distinguishers, but under the covers, the important thing is that in there is that it has IP addresses involved. So this means that when you're passing around things that, as part of our feature set, contain IP, a big portion of the headache you have to deal with is that they can actually pass back and forth from context that might be scoped locally. That's the whole point of a virtual private network. Or maybe it actually touches something, gets redistributed into the internet. And certainly with these days, we have specialized applications like BGP fabrics, that BGP is used to bounce stuff around as a switching environment. Those things interact in many circumstances, not only with VPNs, but also with internet contexts. So stuff is expected to be limited scope. You have to be very, very careful about, does it leak or not? Does it grow? Does it transform from one thing to another?
I think if we ever rev this deck, we need to put a hold my beer meme in there. Yeah, so error handling, a subject near and dear to various scars that I have, and Jeff has too, and probably Warren too. So RFC 4271 is completely biased towards correctness, in that if I'm a BGP speaker and I receive something, a thing that, remember that attribute that I formatted incorrectly and gave to Jeff, who gave it to Warren. Well, when Warren got that attribute, he looked at it and said, "This is formatted incorrectly. Oh, whaley, something has gone wrong on this BGP session. I can't trust anything about it anymore. The only thing that I can do is reset it." And that's awesome, because that BGP session was carrying, 1 million routes and a very large amount of customer traffic, which now has to slosh somewhere else. And people become unhappy. Happy eyeballs or no. And all because I formatted a path attribute wrong that actually maybe nobody even cared about. Maybe it was even just like some test that I was doing. This is horrible for a number of reasons. One is like, the thing that I just said. Also, there could be a lot of Warrens. I could have sent it to Jeff, who could be a route reflector, who could have replicated that route out to, several, all of you. In fact, I could be the only person in this entire room that doesn't know how to properly form this attribute. All of you could know how to do it properly. Jeff sends it to all of you, and all of you reset your sessions to Jeff.
And when we come back up, we make our sessions again, and you send it straight back to us.
And then we do it again.
Yeah, this is like daycare. You bring your kids off there. One kid's got a cold, it brings it to everyone. So, as John's mentioning, it was like we had incidents that caused us to decide that something needed to change in the protocol. So 7606 came around, and our focus was stop dropping sessions, stop shooting the messenger for things that they're passing along, but they're not the actual fault for. So,
sort of a principle of minimum necessary force instead of maximum force.
Yeah. So, this was targeted towards increasing the resiliency in the face of original correctness. It's not perfect. It's really tricky to get right. It's where we spend an awful lot of our time in IDR is analyzing new features to make sure that error handling can work in a safe fashion. The problem is when things go wrong in BGP, black holes happen. You have things like zombies. BGP is a stateful protocol. I hand something off to you. You're expected to remember it. You're expected to use it until you hear something different. So if we get something wrong and you accept it and the session's still up, it's going to stay that way for potentially forever.
I send the route to Jeff. He sends it to Warren. Warren looks at it and says, "This route isn't right. I'm no longer going to forward for that prefix toward Jeff." Now he's forwarding way off to the other side of the world. His customers are getting substandard service, but maybe it takes quite some time to figure that out because there's 900,000 other routes that are still forwarding in the right direction, and just this one that's going off the edge of the world and has suddenly had its latency go from 50 milliseconds up to 5,000. Oops.
So we keep on talking about BGP's theoretically key value protocol, and you got TLVs in there for the actual values. Well, if you think about your typical key value protocols, a lot of the stuff we like to build that's easy and extensible and usable, we like to actually have self-describing. Think JSON or something along those lines. The keys are actually present there. You can figure out what it means, and sometimes the structure is allowed to be very relaxed. You can't do that when you're passing around TLVs, and more importantly, when you're incrementally deploying things across dozens of vendors with slightly different interpretations of things, you have to agree what things actually are going to mean. So the challenge you have is, we got one numbering space. We have 1 byte. And despite the fact that this protocol has been going around for 20 plus years, we've actually only gone through 45 of the things we can use. We have a couple that are set aside. We have a few that are deprecated, but more importantly, when somebody screws up and makes mistakes, it's burned forever. Somebody decides they're going to start deploying something and they got some shipping code somewhere, and something falls over and explodes because you handed it to a feature that somebody put in early implementation for, and it's not clean, different feature. Well, the code point's effectively spoiled. So you're used to IANA type things of once you've been early assigned something, theoretically it gets given back after a couple of years. We treat it basically dead for a very, very long time, which might be until the sun goes cold. Clean allocation matters.
Another sidebar. It suddenly occurred to me that we never actually laid down the ground truth that everything in BGP is a lovingly handcrafted binary format. There's, ain't got none of your nice encodings, none of your self-describing, none of your schema compilers, none of your fancy stuff. It's and that's also why, as I was sort of complaining about earlier, a lot of our formats are just slightly idiosyncratically different because they're lovingly handcrafted by whoever happened to be holding the pen for the spec at that moment.
And this is in radical contrast to our Dr. Tony P from the beginning, who loves his Rift, and his protocol is very lovingly schema driven. Security. This is always something that's very exciting topic when you start talking about BGP. The internet is blown up. Somebody's hijacked my prefix, and what do you do about it? And yes, we'll be mentioning BGP sec. So talking about some very boring pieces. Again, BGP runs over TCP port 179. Why do we run TCP? Well, because back in the day, the folk that were putting together didn't want to invent their own transports, and just as importantly, they remember EGP, which actually did its own stuff wrong. And they didn't want to be responsible for the bug. They want to be able to point to somebody else that, this is up to TCP. Gives us the boring things we care about. It's reliable, it's stream-based, and that means that we can encode large PDUs in there. Think your typical Ethernet 1500. Well, BGP packets are 4K, which you can't necessarily do over that unless you got jumbograms. It's a stream. It works perfectly fine. But this also means we get every single SYN that TCP is going to give us as well. That means that if you have slow sessions, stuck sessions, drop packets, 10% packet loss in TCP, your throughput goes completely to hell. So these are all things that you have to worry about. And this side effect that anybody that works on BGP for any length of time eventually becomes at least a low-grade TCP expert. TCP doesn't give us privacy. Theoretically, you could use IPsec for that, and BGP over IPsec works perfectly fine. The gotcha is that just boring TCP is vulnerable to attacks. Why is this important? Well, BGP sessions sometimes stay up for months and occasionally for years. This means that if you have something up and you have somebody that knows there's probably a BGP session there, gee, there's a router here, it's an edge router. I think I know this thing's advice. Let's go ahead and poke the bear. And very early on, people were doing nasty TCP reset attacks, which in very short order for IETF.
Right, resulted in TCP MD5 being invented, implemented, specified, shipped in, I don't remember how long it took, but it was like under a year, which was pretty impressive. Like people look at it now and they complain, oh, well, it's got, this problem or that problem. But, when you consider that people, the internet was getting, kicked over by people, by script kiddies, it's I think a pretty good invention under fire. It has now been replaced because, or is in the process of being, let's say, deprecated and gradually eased out of the network, because every time you say to anybody who's got like even a little bit of a sec flavor, and you say, and I'm of course using MD5 to protect myself, they say, are you insane? And there's a nuanced discussion to be had, but once you're having a nuanced discussion, you've already lost, so it's better to just invent something modern.
So security of the data itself, it's like, even if you protect the transport, BGP is a route by rumor protocol. John hands the thing to me, I hand the thing to Warren. Well, how does Warren know to believe the thing that I handed to him? I could be handing him anything and claim it's from John, which has caused a lot of hilarity in terms of how BGP gets operated. People will sometimes accidentally lie. They'll take somebody else's routes and announce them. Some people will re-announce them and change the attributes in some strange way. BGP expects, as part of its normal behaviors, to change things hop by hop often. So this means you don't get to do something like an IGP. We're not flooding. We're not able to sign the entire packet. So we have to do something else. There's a tendency to want to use the AS path, which theoretically looks like this path vector of where we're passing the routes through from provider to provider. Well, its main purpose, aside from being useful for route selection, is to prevent routing loops. It can actually give you a sense of who touched it if you could actually believe them. Paths can be forged.
So yeah, the address space is, unless we're talking about legacy address space, which is a whole nother thing, assigned by RIRs, and it's more or less hierarchically distributed down. The history of trying to secure BGP has looked very much like, I mean, it's looked like whack-a-mole, and it's looked like trying to pluck the low-hanging fruit first. And a lot of the early low-hanging fruit was, oh, I fat-fingered my router. Oh my gosh, dearie me, I seem to have announced, my entire continent to you, and I really didn't mean to do that. So the nice characteristic about that kind of thing is that it's unintentional, and I didn't go in and deliberately mess with the AS path to make my illegitimate announcements look as though they were legitimate. So for that, you can, there's a really fairly simple and fairly well deployed now technique called origin validation, which helps protect a lot against that kind of oops. But it still doesn't protect you very well at all against somebody who's lying to you on purpose.
So the question is, what can we do about the lies? Once you start talking about that thing, assuming you're not actually trying to make money by selling expensive CPU, you start talking cryptography, and in BGP land, that tends to mean we're talking about BGP-SEC. BGP-SEC is a mechanism where we sign the AS path hop at a time, along with the destination that's being carried. And in principle, this means that if everybody's exchanged all the necessary keys, you can validate that, everybody that's gone along the way has touched this thing, they've signed it, you can believe it if you're willing to validate it. This does remove AS path forgery as one of the pieces of attack. Unfortunately, why
By the way, just like all kinds of security, you have to get like really nitty gritty about exactly what your threat model is, and there's like a whole page full of asterisks.
So why can't we get this thing deployed? This thing pops up, in conversations with regulators on a semi-regular basis. And we have to tell them, this is why not. So part of it is just simply that anything that is a PKI, as anybody who is one of the actual security experts in IETF is going to tell you, PKIs are complex. And well, that said, RPKI origin validation's proven that at least some level of it is tractable for operators based on the model we're working through today. And that's for a relatively small set of things, set of prefixes and the origin ASs that go along with them. Origin validation's unfortunately also proven with RPKI that errors can happen at the people running those PKIs. We've had actual outages in the internet from people when there's been screw-ups inside of RPKI. You have to be willing, since it's a PKI, to trust the hierarchy. There's reasons to not trust the hierarchy. One of our former ADs will tell you in explicit detail about such thing if you care about it. But fundamentally, you have to have that trust. And if that trust doesn't exist, and more importantly, since it's distributed around the planet, you have to trust somebody that's maybe not in your own region, depending on what routes you're trying to use. But assuming that you actually are willing to trust these things, assuming that you think that this is tractable, crypto is expensive. It's part of the whole point. You want to actually make sure that you can get the job done, and this usually means solving problems that are hard. Signing in the algorithms that's specified for BGP-SEC is actually reasonable cost. Validation, unfortunately, becomes more and more expensive as the AS path gets longer. And this has an unfortunate disproportionate effect on the edges. Sometimes there's smaller ISPs that are running older equipment. They would take part of the penalty. And quite honestly, the biggest problem, and this is where I spend an awful lot of my day job, is that your CPU, all your CPU belong to BGP. We use the CPU as hard as we can, and often the boxes are sized for that. So the problem is, if you're already really busy with stuff, adding all this crypto on top of things is a interesting choice. Are you willing to degrade your performance, your convergence time, and does the security really buy you anything for these, at the moment, are edge cases? The other problem is that the signatures themselves end up making things large. In older systems, maybe don't have a lot of memory lying around. There are people that get really annoyed if you actually throw an extra couple of B2B communities on things, it can blow up your data structures. If you're having that conversation, you're not ready to actually put BGP on your router.
One other footnote on this is that not noted there, but all of the crypto operations are public key operations. Unlike some crypto things that we do in our other protocols where we use, do a public key handshake at the beginning, exchange a symmetric key, and then everything is symmetric key after that. No, that's not how this works. It's all, object level security, and everything is a public key that's associated with more or less with an AS. So that makes things harder.
So the other problem is that BGPsec does not solve all the problems. And this is one of the other unfortunate conversations when you have to talk to regulators that are zealous about deploying BGPsec as the end all and be all. BGPsec only can verify that the router has touched all the things in the AS path. It doesn't guarantee a single thing about how traffic flows across the network. So if you've seen some other BOFs running through and some other proposals through IETF, both in IDR, CIDR-ops, and other things about assured forwarding, things have been touched. Those are not necessarily guaranteed out of BGPsec. Now, this is just saying that the router's touched it. How it gets forwarded is up to you. Just as importantly, since forwarding in BGP really depends on all this other stuff in the dump truck, that impact forwarding, tunnel encapsulations, communities that redirect things, pick all those random bits of magic that people keep adding in. Well, BGPsec only covers the AS path itself.
Right.
So,
it addresses one very important piece of the attack surface, but there are lots of other bits of attack surface still left.
Yeah, and part of that is replay. BGPsec doesn't stop replay. What the PKICs and other crypto folk are going to tell you is the best answer is to rotate your keys. You tell people in BGP land that you're going to do an operation that involves reannouncing your entire table, they're less than happy about these sort of things, and that's the tool they're given.
Right. The analysis is fairly unattractive of everybody reannouncing all of their routes on any kind of a reasonable rate.
So it also doesn't help you secure your peering relationships. BGPsec just simply says that, yes, you're allowed to pass things from A to B, and it's actually touched there. Doesn't actually tell you whether this is bad touch or not. So part of it's also just simply bang for the buck. Anybody that's studied security in any flavor knows that security is fundamentally about trade-offs, and that we have different expectations depending on who's involved in the system. And part of this is there are different motivations. Some people might have need for perfect security. Some people might want okay security. If you make the cost the same for everybody, one size does not necessarily fit all. Just as importantly, if you're misdesigning your protocol, you can't fix it after the fact. Now, BGP, just like most of the things in IETF, was not originally designed for secure behavior. So we're trying to actually figure out how do we actually plug these things after the fact.
Yeah, I would personally call that more, not so much you can't fix it after the fact, because I don't want to say that it's impossible to fix, but it's a lot harder to, it's the proverbial rebuilding the plane in flight.
So peering relationships we mentioned are not protected. That's a problem that's being looked at across various working groups. BGP doesn't really care from a protocol perspective what sort of ISP you are. What's sort of interesting is EGP actually did. EGP had a sense of hierarchy, which is a little weird. If you want to have some fun with history, go take a look at the spec. And if you want to have extra fun, start debugging it. Operationally, though, what people tend to do for service providers for years has been called valley-free routing, Gower-Exford style routing. And the general idea is that a provider of a given level of hierarchy, having passed it up, doesn't usually expect it to go back down. You're all sort of effectively converging towards the core, and the core will actually bounce it your way. Things go wrong when you violate that thing, which actually might be policy in terms of your configuration and policy in terms of contracts you've actually signed with people. I say that I'm not supposed to announce these sort of things, and when you do, you have things like you try to yank all of YouTube's traffic, through a tiny service provider in the wrong side of the planet. And these things are usually just oops in the most cases, but the protocol can actually do normal things through misconfiguration that have significant planetary consequences. When we have this sort of accidental hijacking, that's one thing, malicious. Once you actually have defined this as a thing that you can do on purpose, you start worrying about how do you deal with it. We have two tools in flight right now, both of these being worked in out of CyberOps, and actually now open policy ran through IDR. These things are allowing us to actually start validating the peering relationships themselves.
I think the main takeaway on all the security stuff is, number one, it's complicated, and number two, it's still very much being worked.
So what's in our future? BGP is successful because things have worked out from incremental deployment. You make things extensible, you make them incrementally deployable, and things have actually worked out great. Address families have been a wonderful extension. Allows you to add a new thing, provide structural segregation if that's how you choose to deploy the thing, and allows you to add things sort of safely into the protocol. And stuff goes in the path attributes and generally is successful, but not always. In particular, because these things can pass through ignorant devices. The problem that we have mostly is about scoping. Stuff has gone places where it doesn't matter. Sometimes the stuff that doesn't matter leaks back into some place that it does, and things go kaboom.
There's also been some regrettable decisions made in the name of efficiency. Some of them are just a little bit annoying, which we talked about on Monday, like variable size fields are a perpetual thorn in my side anyway. But also, in particular, some address families contain in the NLRI, which, if all were right and holy, the NLRI would contain only a key. There are a number of address families that contain key material and other stuff. And there are reasons for doing it that way. I'm sure that I know for a fact that it makes implementations more efficient, but it really makes, it turns out that it makes the deployment story a lot harder.
Yeah, and a lot of this is about building limited domains for things. A lot of the VPN type features we're doing at best, those things don't generally belong on the internet, and we don't really have a good way to clean house behind us. A lot of these things are impacted by transport headaches. If you're actually carrying around the dump truck, efficiency of transmitting stuff on the wire is very interesting. We have some, nice work going on to see about carrying BGP over other things, including QUIC. We were sort of desperate for some features that would make things nicer for BGP at the, literally the internet and the layers above that. QUIC is one option that we're exploring for some of these things, because in some cases, extra type OSI layer 5s, actually having a proper session layer, being able to send multiple things in parallel, that can actually let us structurally segregate within the same session different address families, so that we don't have to worry about quite the same level of pain if something in one address family accidentally takes down the whole system. It also makes things like graceful restart potentially a little bit easier, because if you have things on nice framed layers, well, that means that you can replicate PDUs a lot easier between two systems that are supposed to be sort of in sync with each other, so one can take over from the other in case of failure.
Just as a very quick outline of this graceful restart bullet, the base protocol has, remember how we talked about how it was biased in favor of correctness, and if I saw any kind of an error, I just said, you're insane, I'm resetting the session. Well, at time of session reset, you had a complete copy of all of my routes. I had a complete copy of all of your routes. There's no way in the base protocol to reconcile those. When I bring up a new session, it just all starts from square one. The cost of exchanging all of those routes is linear in the size of the routing table, more or less, which the routing table has gotten kind of big. So that no longer looks like maybe such an attractive operation to have to do casually. And hence this bottom bullet where there's been quite a lot of lines of code under the bridge trying to reduce the number of times when we actually have to do that full routing table exchange. Gosh, it would have been nice if we had a design that didn't lead to that, but we do.
So part of it is, building application profiles for resiliency is something we should look at. Right now, it's almost impossible to go to some vendor, including us, and say, we want an implementation that doesn't have everything. One set of coders are usually working on one big code base if you're very lucky. If you're not lucky, you have a dozen different code bases doing roughly the same thing, maybe with different forks. So, and if you're a service provider and you want to intentionally filter things that are only important for you, it's one step tricky. We talked about earlier how those code points haven't been burned very fast over the years, but over half of them have nothing to do with the internet. There's a lot of service providers that would like the feature that says, throw away anything that's part of this VPN stuff. I don't care about it. Don't ever let it get near me. And we don't really have that as an easy mode right now. That's probably a discussion topic we'll be having in IDR sometime over the current year. Trouble is, we don't want to filter things by default. Just because attribute 100 isn't defined today, well, what happens when it is? Maybe the internet service providers will actually care about the new thing.
Right. The fact that filtering these things is not a first-class feature of most implementations, hasn't been out there very long, isn't heavily used, is I think probably the reason we still are using BGP. If everybody had started out, on day one saying, I'm going to filter out everything I'm not using, the protocol would have ossified right away, and that would be that.
Yep, and once you get into TLVs themselves, as John was saying earlier, sometimes the best answer is to throw the thing in an existing feature rather than trying to put something new together. But the minute you start doing that, how do you filter slices of TLVs? That starts getting tricky. Your policy starts becoming really hard to write. Ships in the night should have been easier. If you didn't plan on keeping things separate, it becomes really easy for things to start overlapping each other. Right now, the protocol really wants to have a single peering session between two devices on the same addresses. There's no easy way to do multi-session as part of the base protocol. And even if you have that sort of thing and you have them running in parallel, policy starts getting nasty. So implementations tend to go towards monolithic, for code sharing. And what this means is operators end up with features that they don't care about, which means that they have bugs that might be in the code path that they shouldn't be getting tickled by. BGP is perfectly happy to deal with things as an ignorant speaker. Maybe it's nicer to be able to say, I want to play dumb. I don't care about this thing. If it passes through and hits somebody that actually cares about it, well, that's their problem.
Hey, Warren, ask me what the difference is between a good feature and a bad feature.
Hey, John, what's the difference between a good feature and a bad feature?
A good feature is a feature I want, and a bad feature is a feature you want.
Yeah.
So address families, we added it. It was incrementally done. We talked about it on Sunday, and this is the thing that worked out really great. RIB is a database that analyzes just the key, and no.
Yeah, if only. If we would have been thinking about it a little bit more in those terms, we probably would have designed it a bit differently. But as I mentioned earlier, we've got all kinds of NLRI that you can't just treat as an opaque bit string. Why does this make me sad? It makes me sad because it means that every time I want to use a new AFI-SAFI for something, I have to teach my entire network infrastructure about it so that the thing can transit through the network. Unlike path attributes that have a transitive flavor, AFI-SAFI do not have a transitive flavor that can just flow through a route reflector without the route reflector actually knowing the nuts and bolts of the semantics of that AFI-SAFI. That was too bad. Yeah,
and unfortunately, when you have path attributes, you can be ignorant of those. NLRI, you don't get that option. And as a side effect, this means that we can't generically do the treatise withdrawal behavior from the error handling document so that we can safely deploy these things on ignorant stuff.
Everything is lovingly hand-coded.
So trust domains do need to be better in the protocol. We've managed to actually do a fair job in terms of allowing flexibility for operators via policy. We have RPKI. RPKI has roots. For, again, who do you trust? Do you trust the hierarchy or not? Well, that's a way of actually building a global level of stuff, but that has interesting operational challenges all on its own. Applications can provide their own scoping, especially if you're cooperating with adjacent service providers, but that's doing a lot of work that is going to be covered in scoping work and IDR soon. The bigger problem we have is that when you start worrying about how do we throw these things out, how do we split things, how do we decide that my feature is better than your feature, or my network and reachability is better than yours and I'm not willing to trust yours, we start heading towards the splinter net.
Yeah, so maybe I complained enough about encodings already. I think a lot of this has already been said.
Yeah, it's all overlapping. And basically a lot of these were covered in our IRCs slide from Sunday. If you're doing nice regular TLV formats, you have nice regular simple code. Well, bless our ancestors that worked on the protocol, this didn't work out so well for us. Maybe there's some work for us to go to something schema driven. Maybe in BGP 5, whatever that ends up being in the future, we can do better. But that said, we're 20 plus years in the BGP 4 and we keep on gluing in extra features. So we'll see.
30 years.
Oh, 30 years. I'm feeling old. Better framing layers, as I talked about. This is something that IETF as a whole would benefit from. We have Quick. Quick isn't quite a nice framed layer, but multiple streams help. That's something that'd be nice to talk to. One of the other headaches for BGP is that all these NLRI are just crafted into one big bit string. Well, there's nothing that makes it easy to parse things out and know, did I successfully parse a completely valid set of things? Or do I have a set of malformed things that just successfully parsed? There's no way to actually check that right now. So how do we get to the future?
How do you eat an elephant?
Yeah, one bite at a time, one day at a time, one internet draft at a time, and an awful lot of the chairs making unhappy faces at the microphone. This is IETF. We get here because we're trying to make the internet better. BGP's managed to successfully be extended. We've done things incrementally, and this is a sign that we've been successful. At some point, we may want to actually change things on a holistic basis, and maybe then it's finally actually time to call it BGP 5.
Tomorrow.
Thank you, everyone. We have time for questions if such things exist.
Hello, Elliot.
Hello, Elliot.
Hey, everybody. First, thanks for this great overview and actually deep dive. I want to say, first of all, that this is probably, it was not only was the talk good, but the comments in the chat really are hysterical. So I suggest you go back and review them when you have the opportunity.
Awesome. Thank you.
Two points, I think. The first of which is that Brian and I have been sort of trying to figure out how to look at futures from a BGP standpoint or interdomain standpoint. And as the independent submissions editor, I actually have several submissions right now from the Scion group who are looking at endpoint-based routing mechanisms. Their goal was to sort of introduce a security as a first class concept, but there's what your talk demonstrates is that the devil is all in the detail, right? In terms of going day by day, getting operational experience. So in terms of BGP 5, right, what are the things and what would you want out of a BGP 5 and what might you pull from a concept like Scion, and how could we avoid, let's just say, the morass that BGP sec has been in terms of trying to get it deployed, and I use that word morass advisedly. Let me stop there. And again, thanks for the talk. I thought it was excellent.
I think that is an awesome and thought-provoking question, and I'm not going to try to address it on the fly, but I would like to offer to, get together with you and have a detailed conversation at, some point of mutual convenience. I don't know if Jeff wants to try to do this live.
At least the one piece live. So Scion is, a bit about the forwarding model. So BGP can sort of be, twisted a little bit to do Scion. And I think a little bit vice versa. Scion sort of looks like, fat ASs from our perspective. I have some questions about the internal forwarding models I didn't intending to, give to the Scion authors, but clearly their experiments are going well, and we look forward to maybe seeing how these things cross-pollinate.
Okay, I'll just add one last comment, which is I hope I'm looking at 2 reviewers for this work.
Sure, sign us up for yet more.
There's Rudiger
work.
there. I see him. And
that would give a negative review. 2 points. One, as you were talking about the RPKI-based security, I started thinking, it took us so many decades to actually do it, so that we are using technology from a time when nobody was thinking about post-quantum. And I guess that's going to hurt.
there is at least algorithm agility of a sort in BGP-SEC, but I mean, the fact that exists does not mean it's going to be able to transition to PQ. That's like beyond my pay grade.
Yeah, well, okay. The underlying X509 probably already is the base problem.
Yeah.
The other point is, yes, I could imagine a holistic rewrite of the whole thing, and I would deem such a BGP5 as something that's never going to fly.
This is another thing that, probably deserves a much longer discussion in a bar somewhere. I have some thoughts, but go on.
Yeah. But for actually improving the things where you were talking about, well, okay, the handcrafted bit string level of data structures, which remind me of a state of the art in the 50s before assembly language. And yes, at the time when BGP was first drafted, kind of things looked very different from now. A large router had a RAM of not more than 1 megabyte. In the meantime, and in particular in pretty recent years, we have made major progress in the domain of data structure definition and handling in IETF.
Yes.
And kind of very rough sketch, do 4.1, allocate an AS path attribute number that has not been used so far, and define it is starting a CBOR object.
Mm-hmm.
And all of the tools that are recently available become available. And kind of a nasty question would be: can you estimate how much effort can be cut from IDR work because of not discussing any presentation layer fiddling?
2 sets of meaty things. So the post-quantum, I think, is an excellent illustration about why BGP-SEC is challenging to deploy, because even if you had infinite CPU to throw at the job, what you're actually talking about for BGP, because it's planetary wide, is how many tiers of N-class citizens are you willing to create by people that can do all the crypto on their BGP versus the ones that can't. So this is a thing to keep in mind as we're looking at any security features. At some point, somebody can't afford the crypto. We have to make sure that they can still use the internet. The second piece in terms of representations, CBOR is a very nice format. Self-describing schemas can help us to some extent. The biggest problem, one of the things we know dear from BGP, in terms of validation, even if you have flexible encodings that have correctness built into them, which is a nice property to get out of CBOR, the data matters. And what the data is for, the semantics, those types of code bindings are things that self-describing is simply not going to help you with. The real challenge isn't schema. We've had chats with this with Tony P about Rift and Thrift. Having a schema is great. Having the semantics nailed down is wonderful. Now the trick becomes in your incremental deployment story, how do you teach the planet as a whole about the next schema?
One tiny back question. If the self-describing CBOR does with a schema definition that is using symbolic names that will be well chosen, yes, by itself, it does not help about the semantics, but neither do the ASCII art diagrams.
Exactly. And, like CDDL for CBOR gives us, one step towards, better schema. That said, again, how do you distribute around the planet, the semantics, what they mean, and just as much, how does the software plug into the stuff? Brian.
Hello, good evening. Thank you very much for the talk. This was super exciting. And I actually learned some things. There was a point you made on the way to sort of like the future that Quick is not a framing layer, which is true, but it's getting pretty close to being a framing layer construction kit, right? So I'd actually like to know where the work is happening to look into maybe BGP over Quick, and how, as somebody who thought a lot about how to build other transports out of Quick, how I can help with that.
So myself, Jeff Tansura, Ying Zhen, and Alvaro Rotana are basically taking a stab at the first round of BGP over Quick. Our goals for the thing are to leverage the good features that we have out of the protocol today, which is streams for AFI-SAFI separation. It solves a huge problem for BGP being able to survive when things go awry. Quick gives us the multiple streams. They don't necessarily give us, unfortunately, one of the other things we want out of a framing layer, which is where one frame starts and one frame stops, that the OS that can actually run this layer can do to help us with things like nonstop routing. So this is about letting something outside of the BGP ecosystem not only absorb the frames, but also pass it over to other layers in a more transparent fashion.
So Brian, do I correctly understand that you probably would be interested in having at least a preliminary discussion with these guys to see if there's...
Absolutely, yes.
Great.
Because I'm thinking I don't want to make stuff up, in the TDD, but I'm thinking there's probably some connection ID trickery you could do here.
Okay, this time has been well spent.
Excellent. And
cool.
let Ying Zhen have the microphone in a second as part of the follow-up. One of the things that I think is a useful piece of the exercise we're going through is, as best I know, we're probably one of the first control protocols, routing protocol style things in the IETF trying to do stuff with Quick. So a lot of the things that we're stumbling over is a good learning exercise.
So, yeah, this is Ying Zhen from FutureWay. So as one of the co-author of the BGP over Quick draft. So as routing people, we are trying our best to understand Quick, but we will need help from, we'll honor to get help from Quick people. So we make sure we use Quick streams correctly, or if there is something we can do better, that would be great. So looking forward to the collaborations.
Cool. I will go read the draft and then we'll set something up. Thank you very much.
Yeah, we'll send you an email and we'll connect. Yeah.
Cool. Thanks, Brian.
Tony.
Hi, Tony Lee, Juniper. Couple of things. I wanted to point you at Scion to look at very much its security architecture. Scion does not assume that we have hierarchical CAs. And this is probably the best thing about the proposal. The problems that we have had with blast radius of CAs is a serious issue. And Scion just avoids that because everything's local. Now that has some transitivity properties, that has some trust properties, and security folks should give us some good advice and have a long discussion with us. I'll buy the beers. Second point about Scion, look very carefully at the data plane. I looked at it. It has certain things that are interesting, but one of the problems it has is that it allows the originator of the packet to mandate the path. That sounds wonderful, but that means that the transit providers cannot do traffic engineering anymore.
Right. The commercial implications of that are vast, I would think.
I was going to go and say fatal. So I got serious problems with that, and maybe we need to have a thought about that.
Yeah.
Point 3, back on schemas. Schemas are wonderful. They get processed, and then they spit out code for you, and then somebody updates the schema generator, and you're screwed. This is a problem. Don't jump blindly to schemas.
Oh, nobody is doing any blind jumping.
And especially in terms of blind jumping, Joop Snijders has spent an awful lot of work working through a well-established thing, X509 and ASN1, and is finding bugs that have been inside of code that is older than some of the people in this room. Maria.
Hello. Does it work?
Hello.
It shows me. Fine. Yeah, Maria Cizinek, developer of BERT. I'd like to note some things on the side. Basically, regarding BGP over Quick, it has some problems with bootstrapping the routers. If you have a completely cold network, you are adding complexity, especially when we are speaking about TLS in Quick. So there would be probably needed some Quick without TLS, probably Quick AO, like TCP AO has. And then I am quite willing to think about using Quick instead of TCP. But with the TLS, we are basically having problems with time bootstrapping, which is not a problem with routers right now. We have problems with certificate revoke lists, and so on and so on. So this is something very much worth consideration. The thing with schemas and CBOR and so, we are currently looking in BERT into a concept where all the data, not data points, but generators and parsers are directly generated from YANG. So we are basically, we couldn't find any useful tool which would do this for CBOR. So we are basically developing our own. And there may be some tool quite soon that would generate parsers and generators based on a given YANG. So if you want to update the API, update the format, you just put something into the YANG and it gets the code for yourself, and you just access it from the other side by names, symbolic names, and so. Yeah, that's it. Thank you.
All we need is quick, but without the security bits.
Well, actually, the security bits is one of the fun challenges we have. So one of the things we have intentionally not addressed in significant detail in the current draft, we're spending most of our time talking about the BGP-ish things. We know that security, especially the certificate stuff, is going to be very interesting. Right now, we don't have, for BGP, any flavor of deep authentication layer. AO just simply says, you have the same shared secrets for a given cipher. And we'll get some ability to start off with authentication where it actually matters. And we know that there are scenarios for deploying ISPs that's actually important. There was a nice presentation on the peering DB stuff during the Grow session earlier this week that might benefit from some level of certificate architecture. But yes, we have to have basically the Dumbo to allow boxes to be bootstrapped. I think Yingzhen has a comment here.
Yeah. So TRS definitely help with BGP security, right? But also, that also puts a lot of challenge for BGP session to come up.
Yep.
And so far, the draft we have focused on the real BGP protocol part. We sort of leave the TLS authentication part separate because that's the part really bring up the quick connection. So, but if there's something the quick or transport expert can, TLS security expert can help us, we'll need that.
Opportunistic, quick.
Yeah.
Exactly.
Yeah.
And
So-
I think we have an empty queue, and that was the last word.
That queue is empty. So thank you, everyone. I hope this was a good talk, and hopefully this will actually be useful for the future as well.
Yep. And if you have ideas for future technology deep dives, different technologies, different protocols, etc., please come and talk to myself or Brian or Spencer Dawkins.
Have a good night and
Thanks,
enjoy
all.
dinner.
Thanks a lot.